Hello everyone. In this question, it is asked that we are to find the value of the difference between the maximum root and the minimum root of the equation x square minus 5 whole raised to the power 4 plus x square minus 7 whole raised to the power 4 equal to 16. Okay. So if this equation has a root, say alpha, which is the maximum root, say alpha max, and alpha minimum is the least root. Okay, it can have more than two roots, but the value of the maximum root and minimum root, this difference, we have to find the difference between this, that is alpha max minus alpha min. Okay, this is what is asked in the question. Okay, so first of all, the equation is of the form a to the power 4 plus b to the power 4 equal to some constant, right? So there is no direct formula for this a to the power 4 plus b to the power 4. Okay, the equation is x square minus 5 whole raised to the power 4 plus x square minus 7 whole raised to the power 4 equal to 16. Okay, so between these two terms, what is the how to say, the middle term between these two expressions? Okay, is there a expression which lies in between these two? So for that, let us find the average of these two expressions. Okay, so x square minus 5 plus x square minus 7 divided by 2. This gives us, in the numerator it is 2x square minus 12 upon 2. So this gives x square minus 6. Okay, I found this middle expression because this expression is equidistant between these two. Okay, that is, I can write it as x square minus 6 plus 1, right? Plus 1 will give minus 5, and this one can be written as x square minus 6 minus 1 whole raised to the power 4. Okay, and this is equal to 60. So now both of these expressions are equidistant from this x square minus 6. Okay, so if I substitute x square minus 6 with y, okay, then this becomes y plus 1 to the power 4 plus y minus 1 raised to the power 4. This is 16. Okay, let y equal to x square minus 6. This is the substitution I've used. Okay, so now this expression is now reduced to a biquadratic or a quartic equation. Okay, the highest power is 4 now. Earlier it was like x square whole raised to the power 4, so it could have been 8th degree polynomial or 8th degree equation. Okay, now it is a biquadratic or degree 4. So if we try to use the Pascal's triangle for expanding this binomially, okay, 1 1 1, then we have 1, then sum of these two will come in the middle. This is 1 2 1, then this is 1 here, then sum of 1 and 2 is 3, sum of 2 and 1 will be 3 again, and then 1 again, and then again it is 1 1 plus 3 is 4, 3 plus 3 will be 6, 3 plus 1 will be 4, and then 1 again. Okay, so these are the binomial coefficients. Okay, this is for degree 0, this is for degree 1, degree 2, this is degree 3, this is degree 4. That is a plus b whole to the power 0, this is this, a plus b whole to the power 1 is this, a plus b whole square, the coefficients will be like this, a plus b whole cube coefficients like this, and a plus b whole to the power 4, the coefficients will be of this form. Okay, so this is the Pascal's triangle. So expanding like this in this fourth power, right? So it is 1 y to the power 4 plus then 4 y cube plus 6 y square plus 4y plus 1, and for minus the sign will alternate between plus and minus, right? So it will start with positive, then it will be negative 4y cube, then again positive 6y square, then again negative minus 4y, then again positive plus 1 equal to 16. Okay, now on simplifying this, we get what term will get cancelled? This 4y cube will get cancelled and 4y will get cancelled. Okay, so we are left with 2y to the power 4 plus 2 times 6y square plus 1 equal to 16. Okay, so on simplifying, if we divide both sides by 2, we get y to the power 4 plus 6y square plus 1 is equal to 8, right? So if we take all the constants to the left hand side, we get y to the power 4 plus 6y square minus 7 equal to 0. Okay, so this now becomes a quadratic in terms of y square, right? This can be written as y square whole square plus 6 times y square, okay, minus 7 equal to 0, right? So this is a quadratic in y square. Okay, so this equation, can it be factorized? Product is minus 7 and sum is plus 6. Okay, so 7 minus 1, 7 minus 1 will get y square plus 7 times y square minus 1 equal to 0. Okay, so this implies the roots of this equation in y square, this quadratic equation in y square will be y square equal to minus 7 or y square equal to 1. Okay, now y square equal to minus 7, this is possible for complex roots. In the given question, nothing is told about complex roots, so we are assuming it is a real root equation. Okay, so we are discarding this. This is rejected because no real roots will give us this solution for y square equal to this minus 7. Okay, so y square equal to 1 implies y can take the values of plus or minus 1. Okay, now what was y? Y was x square minus 6. This is the substitution we used here. Okay, so x square minus 6 equal to plus minus 1, right? So this implies x square equal to 6 plus minus 1. So this further gives us two roots. Okay, one is x square equal to 6 plus 1 will be 7, and the other root is x square equal to 6 minus 1 is 5. Okay, both have real roots. X can take the values of plus or minus square root 7. Okay, and from here x can take the values of plus or minus root 5. Okay, now the question asks to find the difference between the maximum root and the minimum root, right? So alpha max will be the maximum root and alpha minimum will be the minimum root, and we have to find the difference between this. Okay, so in a number line, if you plot these four roots, okay, we have 0 here, somewhere will be 2, somewhere here will be root 5, and root 7 is less than 3, so somewhere here will be root 7. Similarly, here will be minus 2. We extend it further, this is minus root 5, this will be minus root 7. So we have to find the difference between the largest. The largest will be this one, okay, and the minimum will be this one. So difference between largest and smallest root is say x maximum minus x minimum will be your root 7 will be the largest, right? It is to the extreme right, minus the smallest root will be negative of root 7 because it lies to the left of negative of root 5, right? So this is minus of root 7. So after opening the bracket, this will become root 7 plus root 7, so this becomes root 2 root 7. Okay, and in the given question the options were like root 7, root 28, root 21, something like that. So if I take the 2 inside the square root, it will become 2 square times 7, right? So 4 times 7 will give us root 28. So this is the correct option. Okay, in the you can keep it, if it is a subjective question you can keep it up to here, but in the book it was given in an MCQ question. Options were root 7, root 21, root 28, root 35, I believe. So the correct option is root 28. Okay, so in this question I just used the middle expression of these two expressions, because that expression x square minus 6 will be equidistant from either of these. That is, this is symmetric between these two expressions, right? So I can use I can change the equation to this form, y plus 1 to the power 4 plus y minus 1 to the power 4. Okay, then I expanded the expression through binomial theorem, and then the equation changed to a quadratic, like reducible quadratic. Okay, reducible quadratic equation in terms of y square, where y was equal to x square minus 6. Okay, and then solve for y square, then solve for y, and then reverted back the substitution. Okay, so I plugged back in the value of x. from there we solved for x, and then we found the max and minimum root. Okay, so this is it. Okay, thank you.